what is GraphQL and when should we or shouldn't we use it? But first, hi, nice to meet you. I'm Sharakanski. I'm a software developer at a startup called Salto in Tel Aviv, and I use GraphQL every day, both in the backend and in the frontend. And there is my dog, Kinder. But enough about me. Let's talk about you. If you're Mark Zuckerberg in 2003. So you are developing Facebook, and specifically the most important part of Facebook, which is of course the feed. And let's say you are using REST API. Recall that REST API is an architectural style for web APIs where we usually use HTTP methods to either get, update, create, or delete various resources. So how would you design the API for the feed? You'll probably have a /post endpoint that returns a list of posts where each post has text and creation date and many other details. And this works just fine. And after some time, you have this idea to add comments. So you want to show the top 2 comments of each post right there on the feed. What will you do now? Well, you'll probably just add a comments field to the /post endpoint. And this works great. And after some time, you decide to hire a product manager. And she takes a look at the feed and has this wonderful idea. Remove comments, because the feed is too cluttered and it should be nice and clean. So, what would you do now? Well, you can just not show comments on the feed, but if your backend is still returning comments and calculating the top 2 comments of each post, then it's pretty wasteful. So you want to not return comments from the backend. But this is a breaking change in your API, and it also requires some work in the backend. So it's not that easy. Anyway, you decide to do this change, and maybe you are even creating a new API version just for this. And when you're done, your product manager comes with yet another great idea. And this time, it's really groundbreaking. Add comments, but only for the website, because the app should still be clean. So what would you do now? And note that this is not an easy question, because there are many possible solutions, but they all have disadvantages. And let's go over some of them. So, solution number 1, the /post endpoint will return comments. The /post endpoint won't return comments, and then in the website, you'll have to ask for the comments of each post separately. This is called underfetching, because the /post endpoint doesn't return all of the data that you need. And having to send these many requests, in fact, one for each post, is both slow and inconvenient. So let's take a look at solution number 2. The /post endpoint will return comments, and then in the app, you just won't use them. This is called overfetching, because you are fetching more data than you need. So you are returning comments to the app, and then you just don't use them, so this is overfetching. And it wastes time, because your backend has to calculate the top 2 comments of each post, and then you just don't use them. And it also wastes bandwidth, because you are sending these comments to the client who doesn't even need them. It can even waste your client money, because some clients pay for the bandwidth. So let's take a look at solution number 3. You can have a parameter view, and when view equals detailed, then you will return comments, and you will use this view in the website, and you'll use the standard view in the app, and in that view, you won't return comments. The thing is, there are many possibilities. Maybe you want to show the top likers of a post, and maybe you don't. Maybe you care about the author, and maybe you don't. So you'll end up having many views, like simple and simpler and full. And each view will be coupled with your frontend at that specific point in time. So for example, if you decide that eventually you do want to show comments in the app, then you'll have to change your standard view to return comments, even though your detailed view already returns them. So every change in the frontend will be coupled with a change in the backend. And in the end, you'll have so many views, you won't even remember which views you have and which values each view returns. So this is both confusing and not scalable. And as you can see, your API has to be convenient and flexible. So let me introduce to you GraphQL. GraphQL stands for Graph Query Language. And I'll first explain some main concepts in GraphQL, and then I'll explain how GraphQL solves all of the problems that we've just discussed. The first main concept in GraphQL is the schema. A schema is basically a description of your API, and every GraphQL API must have a schema. So in our case, this is what the schema might look like. First, we have the top-level query, and inside we have our top-level queries. Posts, which returns a list of posts, and a single post, which receives an ID and returns a post with this ID. Exclamation mark stands for not nullable. Now the type post has ID, text, and a list of comments, and the comment type has ID and text. Having a schema has many benefits. First, it serves as a contract between the client and the server. So when you're about to develop a new feature, the front-end developer and the back-end developer can first decide on the schema together, and then they can start developing the feature simultaneously because they already know what the API is going to look like. Another benefit of having a schema is that it allows introspection, meaning that when I'm about to use a new GraphQL API that I don't know, I can simply read the schema, and that will provide me with all of the information that I need about which queries I can make and which return values I'm going to get. In fact, how do you query a schema? Simple. You send a post request to /GraphQL, so there is only one endpoint. And then in the body of the request, in this case, we are asking for the posts, and then the text and comments of each post, and then the text of each comment. The result of a query looks exactly like it. So in this case, first we have a field data, and inside we have posts. Each post has text and comments, and each comment has text. Now, if you don't want to show comments anymore, then you can simply not ask for them, and then the backend won't return comments, and it won't even calculate them. This depends on the backend implementation, but it's very easy to implement this way. So the backend will only calculate comments when you explicitly ask for them. This way, GraphQL solves all of the problems that we've just discussed. It helps you avoid breaking your API, because if you don't want to show comments anymore, then you simply not ask for them, and there is no need to change the API at all. And GraphQL solves overfetching and underfetching because you get exactly what you ask for. No wonder so many companies use GraphQL, like PayPal, Twitter, Airbnb, GitHub, and of course, Facebook, or is it Meta now, who invented GraphQL. But most importantly, Salto. Okay, so by now, we've only seen three main concepts in GraphQL: schema, query, and result. And you can already see how powerful and flexible GraphQL is. So let's see two more concepts in GraphQL that also demonstrate its flexibility: mutations and errors. So first, mutations. Mutations are very similar to queries, except they are meant for doing side effects. So it's like in REST, we have get versus post, put, delete, and in GraphQL, we have queries versus mutations. To define a mutation, we simply define it in the schema. So now we have the type mutation, and inside it's a mutation that we've defined for creating a new post. It receives the text of the post and returns the newly created post. To use a mutation, just as before, we send a post request to /GraphQL, but this time in the body we have the keyword mutation, and in this case we're creating a new post with a text of DevOpsDays. And then the result looks exactly like the mutation itself. So data, create post, and ID. And note that we're only asking for the ID of the created post back. And that's another example of the flexibility of GraphQL, because even with mutations, you can choose which fields to ask for in return. Next, errors. So let's say we're asking for a post with ID 1234. And let's say there is no such post. So we want to return error. What does it look like? Well, it looks like this. So now we have the field errors, and note that this is plural, because we can actually have multiple errors, for example, one for each field. And then each error has a message, and it can also have a path, which is the field that we failed to get, in this case, post. And we can also have extensions, which can contain whatever we'd like. And this is important, we also have data. So some of you may not be able to see, but we have data is null. So in this case, the data is null, but we can actually have both errors and data in the same response. So for example, if we ask for a post and then it's text and comments, and maybe we succeeded to get the text, but we failed to get the comments, then we'll get an error with the path of post comments, but we'll also get data for post text. And that's another example of how flexible GraphQL is. And we've already seen some examples for that. So first, GraphQL has partial errors, errors per field, for example, and you can query for exactly what you need. And another example for the flexibility of GraphQL, which we haven't discussed yet, is that GraphQL is actually transport agnostic. What does it mean? It means that GraphQL doesn't specify how the data should be transferred. And it means that GraphQL doesn't even have to be on top of HTTP. It could use WebSockets or plain TCP or other protocols. That's just how flexible GraphQL is. Now, I actually had a version of this talk that ended pretty much here. And after that talk, people came to me and told me that GraphQL is so great, so powerful and flexible that they're going to use GraphQL from now on for everything. And well, this was my reaction. Because GraphQL has many advantages, but it also has disadvantages. And it shouldn't be used for everything. It really depends on your own use case. So the next part of the talk will be about the disadvantages of GraphQL, and the last part will be about some guidelines for when to use GraphQL and when to use REST. Okay, so my main claim for this part is that GraphQL takes time. And I have three main reasons for that. First, the learning curve. So to learn GraphQL, I first had to learn the specification of GraphQL, and then the specific packages that we're using at Salto, which are TypeScript packages, in our case, Apollo Server for the backend and Apollo Client for the frontend. And because GraphQL is pretty different from REST, this took quite some time. And also, because GraphQL is not as popular as REST, then basically everyone at the company had to learn GraphQL. Another reason for GraphQL taking time is its maturity. Because GraphQL was initially released to the public about 6 years ago, and its stable release was only about 3 years ago. So it's not as mature as REST, which means that there are less guides, less tools, for example, for alerting and monitoring and other things, and basically less of everything. But the community of GraphQL is very active, and GraphQL is maturing by the day. And you could say that these reasons are not really inherent to GraphQL, and they will change as GraphQL gains more popularity and becomes more mature. But I also have a third reason for GraphQL taking time, which is inherent to GraphQL. And that is its flexibility. Because as Spider-Man says, with great flexibility comes great responsibility. And let me explain why Spider-Man says that. So let's go back and take a look at a REST request. So we're querying the REST API of GitHub. And what do we have here? We have the method, in this case get. Then we have the response status code. And the status code is telling us if it was successful or not, and also some details about the reason. And then we have the URL. And because we're using REST, the URL is about the resource. So you can clearly see that I'm asking for users, repos, and issues. And then we also have some headers. So in this case, it's some headers that GitHub is using for rate limiting, telling me that I only have 60 requests, and I have already used 8 of them. So as you can see, this is very informative. Now, what does a GraphQL request look like? Well, it looks like this. So the method is basically always post. Why? First, because GraphQL is transport agnostic, so it doesn't define anything about HTTP, and also because the convention is actually to use post even for queries. Next, the status code. So it's basically always 200 OK, and again, because GraphQL is transport agnostic, and also because we have partial errors. So if there is also data, is it really an error? Next, the URL. It's always /GraphQL, and it wouldn't really make sense to have the resource in the URL because we can actually ask for multiple resources in one request. Okay, but why do we care that the metadata of GraphQL requests is less informative? So let's go back to our Facebook example. And by now, we've already developed Facebook, and it's working great, and users just love it. And then, suddenly, some of your users tell you that comments are not working for them. So you start investigating, and you find the bug, and you fix the bug, and everything is fine, right? But then, one of your developers tells you that, wait, why did we have to learn about this issue from our users? We really need to have alerts on failures. And yeah, that makes a lot of sense. And because we're using REST, it's very easy to set up. All you have to do is log the metadata of the responses and then alert based on the status code. So if it's 500 or higher, you should get an alert. And there are many tools to help you set this up. But if you're using GraphQL, then the status code would have been 200 OK. Now, there are other solutions, but they're not as easy and straightforward. Anyway, you set up the alerts, and then everything is fine again. And suddenly, you notice that comments just keep loading and loading and loading. And again, you start investigating, and this time you find out that your database is on fire. Well, not really, but it's just working really hard. And then you keep investigating, and you find out that there are some malicious users that are spamming all of the posts with many, many comments with some ads and links. And because your database is working so hard, now your standard good users can't see their comments anymore. So there are many ways to deal with malicious users, but one of your developers suggests to add rate limiting. And yeah, that's a great idea. And again, because you're using REST, it's very easy to set up. So all you have to do is define this policy to limit all post requests to /comments to 10 per minute per user. And there are many tools to help you with that. So probably you're using an API gateway, and you could just define this policy on this service. So it's a service that receives all of the requests, and usually it supports rate limiting because it's just HTTP. And you define this policy, and it enforces it for you. But if you're using GraphQL, then the method would have been post even for queries, and also the URL is always /GraphQL. So in order to understand a request, you'd actually have to parse the body, which is slower. And again, there are solutions, but they're not as easy and straightforward. So as you can see, GraphQL solves many problems. It helps you avoid breaking your API. It solves overfetching and underfetching. It forces you to use a schema, which has many benefits, and it helps you reduce bandwidth usage. But GraphQL also takes time because of the learning curve, because of its maturity, and because of its flexibility. So how can you choose between REST and GraphQL? Well, I believe that REST should be the default choice because REST is more mature, it's more popular, and if you don't have a good enough reason to use GraphQL, then I think you should just stick with a good old REST. But in some cases, GraphQL is the better choice, and I think it mainly depends on two factors, your clients and your data. So let me elaborate on that, and I have this cheat sheet, those rules of thumb for when to use GraphQL. First, your clients. Ask yourself, how many different clients do you have? And in fact, how many different requests are they going to make? So if there are many different requests, then the flexibility of GraphQL can really help you. And do you plan to support any bandwidth-conscious users? Mainly, do you support mobile phones? If so, then GraphQL can help you reduce bandwidth usage. Next, your data. Ask yourself, how many different resources do you have? How many different fields each resource has? And are your resources really well connected, creating this big graph? Because if so, then the flexibility of GraphQL can help you because, for example, in just one request, you could ask for a post, and then its comments, and then the likers of the comments, and then the friends of these likers, and their names in just one request. But if you don't have that many resources or connections between them, then it won't really matter if you use REST. Okay, so to sum up, the next time you're designing an API, I hope you really think about your own use case and choose the tool, that suits you best. Thanks, and you can reach me out for any questions after the talk. And also, of course, we are hiring at salto.io, and you could talk to me about that too. Thanks.